Solve the 2y dx squared minus 3dy dx plus 2y equals to x squared, given that when x equals to 0, y is equals to 3 over 4, and then dy dx equals to 5. Now, to solve this equation, the first thing we shall take the auxiliary of the left hand side by equating equal to 0. So we take the auxiliary equation, which will be m squared minus 3m plus 2 equals to 0. This is what we are calling the auxiliary equation. Then we factorize this auxiliary equation. We find two numbers. When we add, we get negative 3. When we multiply, we get positive 2. The numbers are negative 1 and negative 2. So when we add, we get negative 3. When you multiply negative 1 times 2, we get positive 2. So we shall write this as m squared minus 2m minus m plus 2 equals to 0. Then we factorize the equation. The common factor here will be m, you take it out, into m minus 2. Then minus the common factor between m and 2 is 1, so it's 1 into m minus 2, like that. So we have m minus 1 into m minus 2. So meaning we have two values of m. We have m1 which equals to m1 which is equals to 1, and then m2 which is equals to 2. So if we have two values of m, then we are going to find what we are calling the complementary function. CF complementary function would be when you get m1 and m2, then complementary function is always given by a exponent m1 plus b exponent m2x, m1x, m2x. Therefore, our complementary function therefore will be y equals to exponent a exponent, our m1 is 1, so it will be exponent x, then plus b exponent, our m2 is 2, so it will be 2x. So this is our complementary function. And remember, for us to solve this equation, is always given by the general solution is given by y is equal to complementary function plus particular integral. So we need to find complementary function and find also particular integral. So at least for us to get the complementary function, we let this equation equal to 0. We assume there's no x squared. We let it equal to 0, and then we take the auxiliary equation of this second order differential equation, which will be given by m squared minus 3m plus 2 equals to 0. So from there we factorize and we have m1 and m2. So if we have two values of m, which is m1 and m2, then the solution will be of that form: a exponent m1x plus b exponent, this is exponent, plus b exponent mx2. Then we say, so this is a complementary function. So what is remaining for us to get now? Particular integral. Now for us to get the particular integral, now that you've been given x squared, so we assume that the particular integral will take this form. We assume that the particular integral will take this form: cx squared plus dx, then plus e. So this one will be our particular integral. So we can let it be y, that y equals to the assumed function will be c exponent cx squared plus dx, then plus e. we differentiate this equation, dy dx will be equal to, when we differentiate this equation with respect to x, so we shall have 2x, we shall have 2x, we shall have 2cx, then plus d. This is a constant. When you integrate, when you differentiate, you get 0. So dy dx equals 2cx plus d. We differentiate this equation for the second time, that is the 2y dx squared. So when you differentiate this equation for the second time, we get 2c. This is a constant, will be 0. So this is what we have. So once we have dy dx equal to 2cx plus d, then the 2y dx squared equals to 2c. Therefore, we go back and substitute these values in the given equation. The given equation, the given equation. So we have 2y dx squared minus 3 dy dx plus 2y equals to x squared. But we are now saying that the 2y dx equals to 2c, so we replace this one by 2c minus 3 dy dx. Our dy dx, which is this one, 2cx, 2cx plus d, then plus 2 into y. Our y is this one, which is cx squared plus dx plus e, plus e equals to x squared, So at this point, we open up the brackets. So we have 2c minus 3 times 2c, so we shall have minus 6cx, then minus 3 times d, so minus 3d. Then here we have plus 2 times cx squared, we have 2cx squared, then plus 2 times dx, we have 2dx, then plus 2 times e, 2e equals to x squared, So from here we try to collect like terms. So we can start with the highest power of x. So we have 2cx squared. Then you go to the coefficients of x. You have this, and then you have this. So we have plus 6c plus 2d, like that. Then we have x. Then of course we also have the constant terms. 3, we have 3d, 2c, and then 2e. So we shall have plus 2c minus 3d, then plus 2e equals to x squared. So from here we shall try to equate the coefficients of x. We shall start with the coefficients of x squared. Coefficients of x squared, you can see we have 2c equals the coefficient of this x squared is 1. So we shall have 2c equals to 1. Therefore, c equals to 1 all over 2. We have the value of c. We can now move on and get the value of the remaining. And now, the coefficients of x squared, we are through that. Then we call the coefficients of x. Now, on this side, we don't have x. So we shall equate this equation to 0. So we shall have 6c plus 2d equals to 0. And then the constant terms, again on this side we don't have constant terms. The constant terms is 0. So the equation will be 2c minus 3d plus 2e equals to 0. So you can solve the two equations simultaneously. But remember here we have the value of c, so we can replace c is a half, we can replace this so that you can get the value of d. So 6, so it will be 6 times a half plus 2d equals to 0. 6 times a half is 3, so 3 plus 2d equals to 0. Therefore, 2d equals -3, d equals -3 all over 2. So this is the value of d. Then we can also get the value of e from this equation. So the value of e will be 2 times a half. We are multiplying the value of c, which is a half, then minus 3 times the value of t, which is -3 all over 2, so times -3 all over 2, then plus 2e equals to 0. So this 2 times a half, we have 1, minus 3 times -3 all over 2 will be plus 9 all over 2, plus 2e equals to 0. So this is 1. The LCM is 2. 1 into 2, 2 times 2, we have 2 plus 2 into 2, 1 times 9. So we have 11 over 2 plus 2e equals to 0. Therefore, 2e equals to minus 11 over 2. Therefore, e equals to minus 11 all over 2 divided by 2, which equals to minus 11 all over 2 times 1 all over 2, which equals minus 11 all over 4. So that is the value of e. Now, once we have the values of the constant, then we say that our assumed pi so we say that our assumed pi was given by c. It was given by cx squared plus dx plus e. So it will be equal to, we can now replace the values of the constant. C is a half, so we can have a half x squared. Then d is minus 3 all over 2x, 3 all over 2x, then plus e. Our e is minus 11 all over 4. So that is our assumed pi. That one is our assumed pi. But remember, we said that the solution of the second order differential equation is given by the general solution is given by y equals to complementary function plus particular integral. So our complementary function was a exponent m was a exponent what? Was a exponent x, then plus b exponent 2x. That was our complementary function. Therefore, the general solution y will be equal to a exponent x plus b exponent 2x, then plus the particular integral, which is a half x squared minus 3 all over 2x minus 11 all over 4. But remember, we have been given the, so once we have reached the general solution, so we can now, from this point, we can move on to get the values of the constant, the value of A and the value of B. Remember, we have been given more information. These are the extra information we've been given that x equals to 0 when y equals to 3 all over 4, and then dy dx equals to 5 all over 2. So this is the extra information we are going to use to get the values of the a and the value of b. Now, they are saying that x equals to 0 and y equals to 3 all over 4. So we substitute direct. So y is 3 all over 4, so we shall say 3 all over 4 equals 2. So when there is x in this equation, we put it as 0. So it will be a exponent 0 plus b exponent 2 times 0, it will be 0, then plus a half dot 0 squared minus 3 all over 2 dot 0 minus 3 all over 11. So any number raised to 0 is 1. So this equals to a plus b. This is 0, this is 0, then minus 11 all over 4. So we have, so when 11 all over 4 crosses to this side, it becomes positive. So we have 3 all over 4 plus 11 all over 4. This one equals to a plus b. So 11 all over 4, this is 14 over 4 equals to a plus b. Therefore, a plus b equals to 14. So 2 here is 2, 2 here 7. So therefore, a plus b equals to 3.5. Now we call this one equation 1. We can also have the second equation. Get the second equation from dy dx equals to 5 all over 2 when x is equals to 0. So we get dy dx, so we differentiate this equation. So dy dx will be equal to, when you differentiate exponent a exponent x, we get a exponent x, then plus when you differentiate b exponent 2x, we get 2b exponent 2x, then plus when you differentiate x squared, you get 2 a half, 2 times a half x, then minus 3. When you differentiate 3 over 2, you get that. So dy dx equals to a exponent x, then plus 2b exponent 2x, then this one will be plus x, we are differentiating this, so we have that. To differentiate this one, we have minus, so this is 2, we have x, then minus 3 all over 2. But they are saying that the dy dx equals to 5 all over 2 when x is equals to 0. So from here we have 5 all over 2 equals to a exponent replaced by 0, then plus 2b exponent 0, then plus 0, then that minus 3 all over 2. So this equals to, this will be a plus 2b minus 3 all over 2. So 3 all over 2 crosses with this side and becomes positive, so that we have 5 all over 2 plus 3 all over 2 equals to a plus 2b plus 2b. Therefore, I can do this equation up there. So I have 8 all over 2. When you add this, you have 8 all over 2 equals to a plus 2b. So this is 4. So we have, therefore, a plus 2b equals to 4. All this one equation 2. So we can solve this equation and that equation simultaneously so that we can get the values of b and a. So from this equation, we can make a the subject. So a equals to b minus, it will be 3, a equals to 3.5 minus b. So this is the value of a, 3.5 minus b. So we come in this equation where there is a, we replace with that. So this equation will be 3.5 minus b plus 2b equals to 4. So minus b plus 2b will remember the positive b. So we have b equals to 4. This crosses with the other side. 4 minus 3.5. So b equals to a half. B equals to a half. So if b equals to half, we can easily get the value of f from here. So a equals to 3.5 minus b, which is a half, which is 0.5. Therefore, a equals to 3.5 minus 0.5 will remain with 3. So we have the value of a and the value of b. Therefore, our equation now is y equals to a exponent x, but a is 3. Now this one will be 3 plus our b is a half exponent 2x plus a half x squared minus 3 all over 2x then minus 11 all over 4. So this will be the equation. Y equals to 3 exponent x plus a half exponent 2x plus a half x squared minus 3 all over 2x minus 11 all over 4. Thank you for listening.